We now prove the completeness of the Hilbert style system. We use a style of proof. So Henkin style completeness proof. Okay. So what is this style of proof? So to begin with, let's do a definition. Consistency. Okay. We say that a formula phi is consistent if it is not the case that we can prove not phi. Okay, so let me write it in English. C is consistent if not phi is not provable in the proof system. The proof system in question, which in this case is the Hilbert style proof system. Okay. So Henkin talks about a property. Okay, let's define the Henkin property. Of the proof system. Okay, so the Henkin property of the proof system is the following. A proof system satisfies the Henkin property if for all consistent formula is satisfied. Okay, what do we mean by that? So recall that the consistency in this property, the consistency is of C in some sense depends on the proof system. Whether a particular formula is consistent depends on the proof system, but once you fix the proof system, we can talk about consistent formula. And Henkin property of the proof system is that consistent formula under the proof system should be satisfiable. Okay, so that means that let's write it down. Consistent phi implies satisfiable. Okay, which is to say that there is a world C such that in that world C is true. Okay, so is a model for C. Okay, now what we show is if so the main idea of Henkin is that if the proof system system satisfies the Henkin property, then it is complete. If the proof system, let's stick to the Hilbert style. The Hilbert style proof system that we saw, if it satisfies the Henkin property, then it is complete. So we will show this. Okay, we will show this, but how do we show this? Okay, so let's think about it like this. So what do we want to show? Completeness means that if phi is valid, then phi is provable for all formula. Okay, let's express its contrapositive. So which is equivalent to saying that completeness means if phi is not provable, then phi is not valid. Okay, phi is not provable implies phi is not valid. So this is just a contrapositive. Contrapositive means A implies B is equivalent to the claim not B implies A. Okay, so we have used the counterpositive in the meta logic. Okay, so we have used counterpositive in the meta logic, so we just need to show this claim. Okay, so we need to show this. Okay, so let us assume the Henkin property. Okay, let's assume the Henkin property. Okay, now so this is an exercise. Show that not beta implies beta in the Hilbert system. Okay, so this is an exercise. We will use this kind. Okay, so we have the Henkin property. We need to show this version of this completeness. That is, we need to prove this claim. Okay, so how do we prove this? Okay, so we know that so let's start. Let us assume that phi is not provable. This is terrible. Let's assume that phi is not provable. That means not of phi is not provable. Why is that? If not of suppose not of phi is provable, then from the exercise and modus ponens we get phi is provable. Okay, we know that exercise tells us that not B implies beta is a claim. Since we have not phi, then we can conclude beta phi. Okay, so clearly not phi is not true. Okay, so what does this show for us? If phi is not true, then so is not phi, neg phi. Okay, so from this we so hence if phi is not provable, then not phi is consistent. Recall that not phi is consistent precisely when this is equivalent to saying not phi is not provable. Okay, so that's the reason why not phi is consistent. So by Henkin, now we assume that Henkin property is true. By Henkin property, Henkin property of the proof system, since not phi is consistent, not phi is satisfiable. Okay, what does it mean to say that not phi is satisfiable? There is a world phi where not phi is true, and hence phi in this world phi is not true. Okay, phi is not true. Therefore it is not the case that phi is valid. Not valid. Okay, why is phi not valid? Because I have shown you a world where phi is not true. It cannot. So if phi is valid, it has to be true in all worlds. So clearly by so how did we arrive at this claim? We make use of the property that if not phi is consistent, then it can be satisfied, and that world will make phi invalid. Okay, so Henkin property implies completeness. Okay, implies completeness, and that is how, so we will be proving this Henkin property. So what is the advantage of proving the Henkin property? So we just have to, so advantage is that we just have to construct a world where some formula is true. Okay, instead of going over all worlds, we just have to produce one world. Okay, so that is the advantage of doing it this way, and this is what we will be doing.